Hi, I'm Ed Sperling. I'm the editorial director of Low Power High Performance Engineering. Here today to talk about sign-off, which is becoming a growing problem as we move down from one node to the next, and as we start dealing with multiple power domains and voltage islands and integration of IP blocks. So here to discuss it today are Simbal Rafiq from Applied Micro, Robert Hoogenstryd from Synopsys, Rob Aitken from ARM, Carey Robertson from Mentor Graphics, and Ruben Molina from Cadence. Simbal, when you think about sign-off, what's the big problem there, and is it getting better or getting worse, and will it ever get solved?
Yeah, timing closure, I think it is getting kind of harder as we go along, but I think overall comfort level, if you're asking comfort level, I think would eventually stay the same. As the technology node develops, the first time you see it, I mean, of course, your comfort level is lower. As the technology node matures, your comfort level actually starts getting better. So in terms of closure, of course, like it's getting harder because you have a lot more parameters to worry about. Things like signal electromigration, again the power, again your in terms of the libraries, your STA tools, the size of the design, more importantly, and the speed, of course, it is getting harder.
So are you as comfortable with designs now as they're going out the door as you were in the past, or is it just more people, more resources? How do you deal with it?
Right. So as the size of the designs increase, you of course need more resources. You need more licenses for the tool because your corners are increasing as you go along. So you need more resources, and you need a lot more people to basically implement the same design. Again, it's based all on the complexity of the design and the application.
When you think about sign-off, is it getting easier, is it getting harder, and how do we deal with it going forward?
Well, sign-off is always getting harder because customers are doing bigger chips, more functionality. Some are going to advanced nodes, which introduces new effects. And I think it's the responsibility of the EDA industry to partner with our customers, with the foundries, with IP providers to come up with methodologies that help customers achieve very efficient sign-off, either in terms of new technology development as well as new approaches and new methodologies, and that's been the focus at Synopsys.
Are we as comfortable on sign-off now as we were in the past, though? Are we starting to get to the point where there's so many variables that you're still, even with all these tools, even with all these technologies, you're still going, okay, this is a lot harder than it was before?
Well, I'd say where we are right now is at 28 nanometer. I think it's pretty comfortable. There's a lot of experience there, a lot of silicon data. Customers have a lot of experience. The next wave that's moving to 28 gets to leverage off of all the experience that's been developed by the industry and the EDA companies and the foundry. And I'd say right now in 20 and 16, it's a little too early to answer that question because I think we're all in the learning process. Initial chips 20 are starting to be fabs so that there's a feedback mechanism into the sign-off methodologies and technologies. And at 16, there's still a lot of process development that's going on. And this is what happens at every successive node is there's this early investigation, early feedback, the tools and the methodologies are tuned so that customers have a practical and very comfortable sign-off methodology.
Rob, from your perspective, is sign-off getting easier? Is it getting harder? And will we ever really solve the problem here?
It's an excellent question. I don't think it's getting either easier or harder. The technical aspect of it is getting harder. There are more and more things to think about. It's harder to keep track of all the various effects that are going around. But at some level, it remains the same basic problem that it's always been, which is how is it that I can be certain enough that this design is going to work and it will yield and produce profit for my company, given what I know about it and what I don't know about it. So that problem it remains a hard problem, but it's primarily, I think, a judgment problem rather than a technical problem. The technical aspects of it are challenging, and our goal, I guess, as an IP vendor is to hide as much of the low-level detail as we can and abstract it away so that the person making the final chip sign-off decision can say, yeah, that stuff has been covered somehow, and now I need to think about these other things.
You have a lot more elements going into a design, though, than you did in the past, which increase the level of uncertainty. You've got power islands, you've got various voltages, you've got lots of different IP that's black boxes, you've got integration effects, you've got electromigration, you've even got process variation. Does all that make it harder to be confident with the end product?
It makes it important. It's definitely important to understand it. So all of those effects are very real and very complicated, but it's not just. It really, from a sign-off perspective, you can't possibly understand it all, I don't think. So I think you have to know to what extent those are covered. You have to ask the questions of the people who gave you the black box. Did you think about this? You have to put safeguards for effects you don't understand very well, maybe a localized high-speed IR drop across your design. You have to start thinking about it from a larger angle, too. Think about the package. Think about the power delivery into your chip, for example, what the impedance is, all these kinds of things. So yeah, there's a huge number of effects, and somebody somewhere has to keep track of them.
Carey, are we as comfortable with sign-off with the final product as we were at previous nodes, or is it just getting tougher and tougher as we start adding in FinFETs, as we start eventually adding in 3D stacked die and things like that?
I think it is getting tougher and tougher, and I think at least in the short term we're going to be less comfortable. As you look at people going to 16 nanometers, they're wrestling with less data, they don't have test chips yet, they're trying to characterize, so there's a lot more unknowns, so you're struggling with that. Those who are staying at older technologies are putting in more complexity, putting in high voltage regions, they continue to innovate and continue to put more and more interesting circuits on older technology, and therefore, there again, how is the circuit going to perform? Potentially a little less comfortable with sign-off. And then the third region is people are going into 3D ICs, and that opens up a whole new set of challenges and complexities where we're dealing with more unknowns. So I think in the short term, we're less comfortable. As we become more sophisticated and understand what these new effects respectively will mean, I think we can become as comfortable, but certainly we're going to be facing some significant challenges that we haven't seen before.
You know, one of the things that you're bringing up here is particularly on 3D IC, we're really mixing and matching technologies and technology nodes. So you may be dealing with some very difficult processes that can be or problems that could be worked out on one level of the chip and then not have to be dealt with further up, right? So process variation, for example, at 14 nanometers is a much different problem than it would be at 40 nanometers.
True. I mean, that is the appeal. There is, well, I'm going to do this piece of IP at 40 nanometers. I know how to sign off this IP at 40 nanometers, so it's a little bit cleaner. And from a cost perspective and from a design methodology perspective, certainly you have some assumptions, you have more data on that node, but you've never stacked up this die, and you've never manufactured that die on a wafer that thin. So there are certain things you can take advantage of, but then there also are some unknowns where just because you did sign this die off electrically at 40 nanometers, putting it into this, you do have system level problems that weren't addressed in a 2D world. That 3D or 2.5D on interposer will bring to bear. Probably less difficult than a brand new system at 60 nanometers, but a few new things to wrestle with.
How about, even on a planar transistor, how about things like margin, which has been the crutch of design for a very long time? We can't get away with it anymore. So what does that do to the sign-off process?
Comes down to, it really puts a lot of pressure on library characterization. So a lot of pressure on those guys generating the libraries that usually have to do it with early versions of the data to characterize it across a number of corners, from both device corners and interconnect corners to make sure that we've got really robust libraries.
Ruben, when you look at sign-off compared to going back a couple nodes ago, is it becoming a harder problem, and where are the problems, if so?
Yes, it's definitely it's harder in terms of the complexity of the designs, the amount of timing views that are required in order to do sign-off, And in general, the overall sign-off flow is becoming a larger and larger piece of the overall design process.
EDA always gets the blame for everything that becomes more difficult. People point fingers, but are the tools that are currently out there or will be out there, are they up to the challenge?
In some respects, no. A lot of the tools that are on the market today have been out there for several years. And anytime that EDA comes out with or wants to develop something new, it takes 2 or 3 years to develop a product, bring it to market, and make sure that it's at a mature state that actually is going to benefit the users. So it takes a huge investment. And what we've been doing, what the industry has been doing in the short term has been adding incremental capabilities to the tools that are out there. And that doesn't necessarily address things like performance and capacity.
And one of the issues also is we don't have the luxury of margin anymore, right, that we used to have in the past. In the past, that was typically the Band-Aid that went on almost every design. As you move forward into 20 nanometers, you can't afford the margin simply because it affects performance and also power.
Right. So excessive margin in the design flows today have a couple of negative impacts to the design. One of them is increased area due to pessimistic slack values, more timing violations. All of these things add up to more cells in the design, more cell complexity, more time to complete the design closure process. They're all negative impacts to this situation.